Okay guys, so we've done the first two parts of memory revision. We've looked at the neural basis of learning and memory, we've looked at the models of memory, and now we're continuing to look at the biological, psychological and social factors that affect our ability and our inability to encode, store and retrieve information. So we're still looking at psychological factors. So one of the reasons why we find it difficult to retrieve information is based on the measure of retention that we use for retrieval. So pretty much, research findings indicate that whether or not information is retrieved from memory and the amount of information that is retrieved depends on the type of retrieval method used. Now, there are three types of measures that we use to determine how much information has been retained. So these measures are relearning, recall, and recognition. Now, they are ranked in the order of sensitivity to information. So what does sensitivity actually mean? The sensitivity of a measure refers to its ability to assess the amount of information that's been stored in memory. So if the measure of retention is really sensitive, like for example, relearning, that will register a memory that is present even though there is a very small amount of memory trace left. So example, if we've learnt something and then we've forgotten, let's say, 80% of it, relearning is good because it can actually detect that 20% that's remaining and it can actually bring it back. Now, if we use a less sensitive measure of retention like recall, then recall may not actually be able to find and access at 20% of the remaining memory. So in terms of these three measures, obviously we have relearning. So this is when you relearn information and you relearn it more quickly the second time. The assumption is there was always some memory available. So what the saving score is actually measuring is the time or trials that you've actually saved through relearning. And this is how you calculate that saving score. Remember that depending on the scenario, you need to talk about either, as I've said before, time or trials. Now, you need to make sure you know how to calculate that saving score. You will not need a calculator in the SAC or in the exam, so just make sure you know the formula. Recognition is identifying the correct information from among alternatives. So really good examples of this are things like multiple choice. They are things like when you identify someone who committed a crime from a lineup. If you are identifying your classmates from a school photo. All of that is recognition. The reason why this is a more sensitive measure of retention than, say, recall is because it actually provides more retrieval cues and they serve as prompts or reminders. So the fact that you actually have all of this information means that you have way more retrieval cues than recall. Now, of course, recall, we reproduce information, with the fewest possible cues. So things like this are short answer questions if I just ask you a question in class. There are three types of recall that we can use. There's free, and that is recalling the information in any order. And that's kind of how you do short answer questions, so in any order. Serial recall, so like if you're following directions or like a recipe, that would be serial recall. And cubed recall is like, I do this a lot, so I say to you guys, it starts with C, there are two words, things like that. So I'm giving you a hint. So you need to make sure you know these in terms of the sensitivity, in terms of what they are. As long as you can identify it, talk about what it is, and give an example, you will be fine. Now we're on to the social factors as to why we are able or unable to encode, store, and retrieve information. So we are looking at memory reconstruction based on Elizabeth Loftus's studies on eyewitness testimony. So, what is memory reconstruction? So, this involves remembering past events and features of these events and then putting them together during memory recall. Now, we know that reconstruction is a very active process. So, we know that when we encode information, we store it, and then when we recall it, we actually actively put everything together again. And whenever we recall a memory or we retrieve a memory, we know that we haven't encoded it properly, so we know that there'll be gaps missing. So when we recall it, we actually fill in those gaps with our own perceptions, our own stereotypes, and things like that. So we know that both encoding and retrieval or recall is a very active process, and that's when memories can become fallible or they can become distorted because of the integration of new information. Now, in the context of this dot point, we're looking at leading questions as that new information that is integrated into an older memory. Leading questions are questions that are phrased in a way that suggest what the desired answer is. So you need to make sure you know examples of these leading questions. So things like, "Oh, did you see the fight that broke out at recess?" Rather than, "Did you see a fight?" What "did you see the fight" is insinuating is that there was actually a fight, when in fact there may not have been one. Another example might be if an eyewitness said that she saw two people robbing a store, but she didn't know anything else other than, I guess, what she saw. So what could happen is when interviewing the witness, a policeman could use a leading question like, "What colour was the girl's hair?" Now in this situation, what colour was the girl's hair is a leading question, because what it's presupposing is that the person or one of the assailants actually was a girl when in fact it could have been a boy. So what's going to happen there is in later recall, new information from that leading question is going to be integrated into the original memory. Now that is going to lead to a false reconstruction of the memory. And so when they later recall it, they not only don't know that the new information is distorted and they don't know what's, I guess, real and false, but what they would then do, or what they're then likely to state, is that they will remember that one of the robbers was in fact a girl when it may not have been, it may have been a boy. So essentially what we're talking about here is prior to this new information, the leading question, whatever, the information was accurate, which may or may not actually be true, but let's go with it. Then new inaccurate bits of information about the event, filling in the gaps of the original memory. Now, when that is again reconsolidated and then again recalled, that is what's going to lead to a distorted memory recall. So what we're talking about here is like three things. So the three things that we need to talk about are the new information. So what vehicle it arrives in. So like our leading questions. The fact that it is added to the older memory. Then when it's later recalled, it's been integrated. And when the information is again reconstructed, the information is distorted. So the 3 points are new information, old information, then after it's been reconsolidated, the reconstruction of that new memory, or sorry, I should say the existing memory, are distorted. So we need to make sure that we know some of Loftus and Palmer's research. So this is the first study that they did, and remember they did it at their university. And so I think from memory they sampled about 45 people. So they showed a whole bunch of participants a scene of a car crash, and they asked questions of the eyewitnesses. Now, the way the questions were asked during the testimony, that actually influenced their memory. So the ivy was the type of verb used in the question. So, how fast were the cars going when they smashed, bumped, collided, hit each other? And what this affected was the participants' estimates of speed. So what Loftus and Palmer found was that if they used verbs like smashed, the participants would have high estimates of the speed of the cars in comparison to if they used verbs like hit or contacted. In the second experiment, they asked the same participants a week later, did you see any broken glass? Now, there was no broken glass in the film, but what they found was that if the participants had been part of the group that had the more intense verb like smashed, they were more likely to perceive there to be broken glass, when in fact there were none. Now again, that's because of the leading question. They had integrated new information from the leading question, i.e., that the cars were going at a great speed when they crashed into each other. So then when they recalled the information or reconstructed that memory again, they assumed that there would be broken glass, because obviously if you've got two cars that are smashing into each other, then of course there's going to be broken glass. And that's what actually led to their perception of there being broken glass. So again, new information is being added in to an older memory. When the memory is reconstructed, it is distorted because they don't know that the new information has been added in and it has actually distorted their memory reconstruction. So this is the last little bit of memory, and this is looking at the biological factors that affect things like encoding, storage, and retrieval. So we're looking at brain trauma. Now, brain trauma is an umbrella term that refers to any brain injury that impairs normal functioning. Now, what we talk about this in regards to is like surgery and disease, such as Alzheimer's. So we must make sure that we are cognizant of the fact that you need to know about how surgery affects the brain structures. So remember, we're talking about, let's get rid of that. So remember, we're talking about things like the cerebellum. We're talking about things like the hippocampus, which is actually really hard to see. Let's make that better. So the hippocampus, the amygdala, that knobby thing at the end, and our cerebral cortex. So how does surgery affect those four brain areas? Now remember, if they are damaged, they just can't engage in the roles that they normally engage in. One result, as we saw from brain surgery, particularly the case of HM, is amnesia. Now let's be clear, amnesia occurs through a few different means. So we have surgery, we have Alzheimer's, it can also be caused through stroke, through the case of Clive Wearing. Amnesia is a permanent or temporary, complete or partial loss of memory, typically as a result of organic cause. Now typically that organic cause is as a result of Alzheimer's or a stroke, but remember, as in HM's case, it can also be surgical as well. So the only type of amnesia that you need to know about is anterograde amnesia, although I really think for you, all of you, it's really good to have a vague idea of what retrograde amnesia means. Anterograde amnesia is the inability to encode and store new memories after the amnesia-causing event. Now that's because the hippocampus has been damaged. So obviously we don't have that structure there anymore that's working properly, or it's dysfunctional. So we can't encode anything new, we cannot store anything new. And this typically refers to explicit memories. Because remember, the hippocampus has a role in encoding, consolidation, and retrieval of explicit memories. Implicit memories, like emotional memories or procedural memories, that are stored in other places like the amygdala or the cerebellum. Now, just as a bit of an FYI, let's really briefly talk about retrograde amnesia. Retrograde amnesia refers to the inability to recall previously stored memories. So, like if you knock your head and you can't recall anything prior to the accident, like your name, your 16th birthday, things like that, well, that's retrograde amnesia. So, dementia and more specifically Alzheimer's disease are some of the things that cause amnesia. Dementia is not something we've really spoken about that much. It is an umbrella term. So, holistically, it's a disorder that affects high mental functions like memory, like attention, like learning, problem solving, all that kind of stuff. It's a general term and it describes a group of symptoms for a larger group of neurodegenerative diseases. So examples of other diseases are things like Korsakoff's. The one that we're looking at, of course, is Alzheimer's disease. So this is a neurodegenerative disease that's characterized by a progressive widespread deterioration of brain neurons, causing memory loss, decline in cognitive skills like learning, attention, problem solving, all that stuff, and personality and social changes. So it's actually not just memory loss that we see here. We also have other changes with cognitive skills. We also have social changes and personality changes. In terms of Alzheimer's disease, it's quite hard to definitively say that someone has Alzheimer's until after they are dead, so through autopsy. The reason is because we can't actually see what's going on in the brain. It's really important that you have a good understanding of what's happening in the brain in terms of the factors that cause Alzheimer's. So we're going to kind of do this in a little bit out of order. We're going to start with our amyloid plaques. So here. So amyloid plaques are sticky clusters of protein and they form in between the synapses. Now, you can see them here, although that's really not a good representation. But anyway, so what they do is they stop transmission of that neural circuit, which blocks the message, obviously. The other thing that changes is our neurofibrillary tangles. Now, they are twisted strands of protein within the neuron. So you can see them in the neuron here. Now, what they cause is cell death. Now, via the cell death, that is also leading to a loss of transmission. So again, both of those things are interrupting the message of the neural circuits. Now, because the neurons are dying, that leads to two other things. One, the brain is going to lack acetylcholine because those neurons are dying. And because we have that progressive deterioration of the neurons, that's going to lead to brain atrophy or brain shrinkage. And so the neurons become damaged, they shrink, and they die. Now, in terms of the pattern of I suppose, atrophy, the hippocampus is the first to go, or the first to be affected. Then it goes around the cerebral cortex. And then the last thing that is, I suppose, deteriorated is the brainstem, which is the thing that is in charge of our autonomic functions. And that's why people tend to die from Alzheimer's. In terms of other things that you should know, it's also good to know signs and symptoms of Alzheimer's. Now, you don't need to know this, in depth, but I would recommend that you have an idea of the comparisons between the early signs of Alzheimer's and the later signs of Alzheimer's. So in terms of early signs, we have confusion, memory loss, slower response time, social withdrawal, and there's impaired declarative memory loss, which is explicit. Now, that is because implicit memories, so things like your fear or more particularly procedural memories, are stored in the cerebellum, and that is not one of the first factors, the first brain areas affected by Alzheimer's. In terms of the middle stages, we have severe memory loss, volatile emotional responses, personality changes, trouble with basic tasks, things like that. More importantly, in the later stages of Alzheimer's, we have severe physical and mental impairment. They might be bedridden. They might have difficulty eating and breathing. More importantly, both anterograde and retrograde amnesia occurs. And this is the case for both implicit and explicit memories, because at that stage, most of the brain has actually been affected. So that is it for the content of memory. Now, I will produce another Explain Everything in relation to the practice act. So if you want to hear me going through that, that will probably be uploaded later on in the weekend.